Hi class, this is the last video on the skills needed for the transformation geometry, and this is on symmetry and invariance. So rather than this being about a specific action and transformation that you can do in GeoGebra, this is about explaining why we do these actions. Why are we using the tools if we could just draw it ourselves, right? The whole idea here is that we're trying to make things symmetrical. Symmetry is when things look like really nice to us because a lot of the shapes or and such are the same. So there's all that kind of symmetry, I suppose, in certain things. And we see this in real life. For example, in the butterfly has a lot of symmetry, right? The wings and the patterns on the wings all look the same if you were to like mirror it. And that makes the butterfly look that much more appealing. And other shapes will also have rotational symmetry involved. So this idea of symmetry is really appealing. And in the purposes of GeoGebra, the question is, why are we using these tools if we could just draw it out? So let's say, for example, I've got this weird intricate shape, and I want to like repeat it 3 more times, like in a circle. So I might go to Tools. I'm gonna create a point. This is where I want to like rotate it around. And I'm going to go to my transformation tool, rotate around a point, click on the shape, click on the point, 90 degrees, clockwise, and I'm going to repeat this a couple of times. Oops, I think I clicked on the line. Here we go. Repeat this a couple of times to make sure I've got the nice pattern that I'm looking for. There we go. So I wanted to get this shape, and I could have gone and meticulously drawn things out, but I'm certain I would have made mistakes. And of course, I'm just using straight lines. If I'd used like curved lines or tried to make something a lot more intricate, I'm certain I would have not done as good of a job as if I had used the tools. And so therefore, the reason for using the rotation tool is because we wanted to make our shape look more appealing by not having any sort of errors, and make sure everything connects really nicely and all that kind of reasons, right? So this is the idea of symmetry. This is why we do it. So there's 2 kinds of symmetry. The first one is reflectional symmetry, where we draw a line and we reflect, right? Kind of like a mirror. And this we primarily get from the reflect line, right? So if we create a reflect line, we will get a lot of reflectional symmetry. So, for example, again, the butterfly has reflectional symmetry. This star has lots of different ways you could have mirrored the star to get that shape, right? You could have drawn a line like this, you could have drawn a line vertically, and then it would have mirrored left and right, or certain angles. So the star has a lot of different lines where you could have reflected it to result in getting a star, right? I could have drawn just this left side of the star, and then reflected it to get the right side look perfectly as well, right? So that's the first kind of symmetry. It's just if you had placed a mirror somewhere on the shape, would you be able to get this shape by doing this mirror thing? The other type of symmetry is the one that we talked about in GeoGebra, which is rotational symmetry, right? Could you have created the shape by rotating an element of the shape a couple of times across? So I got this shape by rotating this right part of the shape 3 more times. This weird leg thing you could get by rotating this right part of the shape 2 more times like this, right? So there's rotational symmetry, and this looks so much nicer than if you had tried to draw it by hand. Because if you had tried to draw it by hand, maybe the star would have not quite been in the right place. Maybe this like elements of the leg would have not quite looked right. Everything would be slightly off. Or maybe the angle of the leg itself wouldn't quite have been right, and then it would have ruined the image. If just this tiny leg wasn't quite on the right spot, the whole image would have looked just off, and you wouldn't know quite why maybe, but you know something isn't quite right. But by using the rotational tools, we can make this look perfectly nice and give us that rotational symmetry, right? Lots of other elements have rotational symmetry. Again, this star, I could have made the star by just taking one of these, what do we call them, like sides of the star? There's like corners, and then rotate it a few more times, and I would have gotten this star as well, right? So that star has that rotational symmetry in it. Look at some other examples. This star, on the other hand, because of its shadows, doesn't actually have any kind of symmetry. I can't draw a single line to give it rotational symmetry, because the shadows would never be quite in the right place if I had mirrored it. And this also doesn't have rotational symmetry. Look at this right wing here. The shadow is on the right. here the shadow is on the right, but on this one the shadow is now on the left of the side. So it doesn't have rotational symmetry, it doesn't have reflectional symmetry. Ignore the text, sorry, the text is wrong. Ignore this. It just doesn't quite seem right and seems a tiny bit off, right? It might make sense in the context, like the light is shining in a certain direction, but in terms of just looking at the shape itself, it doesn't quite seem right because it lacks that symmetry. While, for example, this emoji face, it has reflectional symmetry, right? The left side of the face is exactly the same as the right side of the face. Imagine if that wasn't the case. Would this still seem right to you, right? And down here, this shape as well, the color isn't, like, there's no rotational symmetry here with the color. But if you ignore the color and just looked at the shape, like this intricate shape here of each of the sides of the yin-yang, that does have rotational symmetry, right? The circle is in the exact right place if you had rotated around the center. And if it hadn't been, if this circle had been like slightly too low or slightly too far to the right, this whole shape would have looked off, right? So this is the symmetry in action. So when you give reasons as to why you use these tools, it should be because you're trying to create symmetry, you're trying to make it appealing, you're trying to avoid any sort of mistakes that could have happened by you trying to draw this manually. And like you might get the distances wrong, you might get the shape itself wrong, you know. So by using the tools, we ensure that this all looks perfect and gives them that symmetry. So those are the kind of reasons you might bake in. So I decided to use the rotational tool because it would ... right? The other bit, and the other part I want to talk about is invariance. So invariance, it is a bit more, slightly more high level, but this is you describing, again, like some of the benefits of using the tool. But rather than talking about the symmetry aspect, you talk about the benefits that the tool provides in terms of what changes and what doesn't change. Let's go through an example. In this picture, this tiny triangle here was being rotated around this point to get to here, right? So with the rotational tool, what elements of the triangle stayed the same and what elements of the triangle changed? Well, clearly the thing that changed is the orientation of the triangle. The triangle isn't facing the exact same way as it was before, right? It's now the top of the long part of the triangle is now pointing up here, while before it was pointing to the right, right? And the position of the triangle has also changed, right? The triangle isn't down here, it's now to the right. That makes sense. That's probably going to be the case for a lot of different tools. But what hasn't changed? What stayed the same? Well, the length of each side of the triangle has stayed exactly the same. Like the orientation has changed, sure, but the actual length of each side has stayed the same, which means the shape is the exact same size as it was before. The triangle side lengths are invariant under rotation. So when I used rotation, the side lengths didn't change. And that's what makes rotation very useful. So when you describe kind of why you want to use the rotational tool, you'll talk a bit about symmetry. The rotational tool gave you that symmetry in your design, but you might also say that you used it because by using the tool, you know that you're not changing the side of the lengths. Right? You don't necessarily have to use the word invariant, but you're showing that you understand that the rotational tool gives you the benefits of keeping the shape itself exactly as it was, right? And the same would apply to reflection, right? When you reflect an object, what stays the same, what changes? So let's get rid of this, and let's say I want to reflect this object to get something else. So if I create a line, and let's say I'm going to create a line, oops, so I need to create the line. So it's going to create a line right in the middle of the shape this way, so we can reflect it around the line and get this nice looking X shape. So I'm going to reflect about a line, click on the shape, click on the line, and boom, I've got this nice looking X shape, right? First of all, symmetry. My left and the right looks exactly like perfectly nice because of that symmetry, right? Because I reflected it, it now looks correct. The side doesn't look like slightly off or anything on those lines. It's a nicely symmetrical shape. But what stayed invariant? What elements of the shape has not changed because of this transformation? Well, the sides of this shape hasn't changed. So the length of the sides, sorry, right? So this length D, or of the line D, is exactly the same in its new form. It's just rotated differently, but the length of it is exactly the same. So we know that the left side of this new shape on the left side is exactly the same in size as on the right. But what did change is the orientation. So this is why I used the tool, because I know that it will keep this shape exactly as it is, just now reflected around the line, right? So this is a description thing. So as you describe your reasons as to why you use the tools, describe the benefits, like what is it that the tool can do and what happens to the shape when you use the tool. And that about covers everything with the assessment. Allow me to quickly talk about what you should consider when practicing. So in the next part of the numeracy website, there's some practice tasks you can look at, as well as examples for you to look at. So please look at those examples and note how they are describing the transformations, not just like describing it. I rotated this shape around point H 45 degrees clockwise, for example, but also how they're using the contextual words, like they're talking about it being the tree or the plant or patch of grass or the sail on a ship or whatever the case might be, right? And notice kind of how they talk about the like what the tool does and how the reasons why they use that tool. So keep an eye out on all of that as you prepare yourself for your assessment. That's it. Good luck.